So everyone here, I'd like to thank all of you for joining our webinar on automatic code remediation at scale. As I talk, I'll be letting more and more people in. So sorry for if I interrupt the flow of my conversation. It's very kind of you to take time to join us. I do think you're going to learn a lot, and you're going to see something very special with Moderne, which is an incredible solution. And I'll introduce it in a second. So first, I'll just for those of you who don't know, Optica Consulting, we're hosting this event. We're a consulting organization. We focus primarily in the modernization world. We help companies with their application development, DevOps, containers, and cloud. Our customers include Verizon, Delta, American Express, Bell Canada, large institutions, as well as small and medium organizations. And in our journey, we look for solutions that are really going to disrupt the industry to help improve the world that we live in, which is helping companies modernize their applications. And we came across Moderne late last year, and it was fascinating what we learned. So I'm really happy Jonathan is here. So without further ado, Jonathan, I'd like to introduce you to everyone. Uh, just please a little bit about yourself, if you don't mind.
Absolutely, yeah. Thanks, Yvonne. I'm Jonathan Schneider, co-founder and CEO here at Moderne, and have a long background in our topic from today on mass automated source code refactoring. Having done so, started that initiative at Netflix about 8 years ago, and here we are today doing the same kind of work for large and small enterprise, really.
Thank you for that. So we're going to talk about with everyone today, but we're going to go basically two topics. One is why is automatic code remediation going to be so important? Because there's a tremendous value proposition, right, that you're creating. And then we're going to go over some use cases. One being automatic code remediation for vulnerabilities and upgrading application frameworks. Those are the two that we've chosen. So we know a little bit about each other. Actually, maybe we know a lot more about each other these days.
We do.
We spend a lot of time together. We don't do this very often, but we think actually, so we've been in business for 14 years as Optic Consulting, and what we've seen Moderne can do is phenomenal. It's compelling. So if you don't mind, as you take us through what does Moderne do, can you add a little color to that about where you started? Because I think it's kind of important when you see where you started and where this came about, because I think it'll add even more credibility to the message.
Absolutely, yeah. I think there's two things to really think about. First of all, it's that one that the scale of software, the source code that we're managing, has really grown over the last several years, and I think that has to do with the fact that the software development process has really been gone through an industrialization period over the last 10 years or so. If I think back to writing software at an insurance company, my first job out of school many years ago, it was largely in-house, right? It was vertically stacked. We didn't use a lot of open source and third-party components, running on WebSphere, internally in a data center, and that's just not, for the most part, the nature of software development right now. We're taking components off the shelf. We're taking from our framework like Spring to the like individual database access to a sorting library. I mean, we're taking components off the shelf everywhere, and we're assembling them into customer experiences very quickly and shipping them. What hasn't been industrialized along with that authorship is the maintenance of that code, though. So we're producing lots and lots of it, and then the maintenance activity is very manual. Developers feel that. Every time there's a big library breaking change, they have to go and touch every single point that refers to it. It's very tedious. It's not a creative activity. It's not what we got into software development for. And that's becoming really increasingly burdensome.
One of the things that I found fascinating is the idea, because we see it more and more, right? There's a lot of companies that have reporting tools to tell them what's wrong, right?
Absolutely.
And so you get that noise of all these reports that you get, but companies have limitations in terms of what they can do about it. You represent a new generation, which is, hey, not only can we identify the issues, but we can automatically resolve them, which is a big,
Absolutely. Yeah.
yeah.
Yeah. I mean, here, I totally agree with you. I mean, this is the stat, right? You could look at state of software security ironically, from Veracode, right? 90% of applications are scanned more than once per week, and yet 75% of code bases have existing known vulnerable third-party code. I personally, I don't find this state of this current state to be acceptable anymore. I mean, it's we're scanning, but scanning isn't actually taking action on those vulnerabilities. So we're kind of left with a steady state of insecure software that's really running the core of our business.
So before I continue, I did forget to tell everybody, whoever is on this call, there's a QA button that you have at the top of your screen or the side of your screen. At any given moment, like, we want you to ask questions throughout this whole session. So by all means, ask, and I will actually read it and present it to Jonathan. So yeah. One more thing before we begin. You started this off at Netflix,
Yeah,
right?
yeah,
So can you tell me a little bit about, because I always find it fascinating what you're going
yeah.
through, and
It's an
you
interesting
gave me some
story.
good insight into developer reactions. Like, I can't fix anything. Don't bother me
Right,
unless
right.
you do it. Go ahead. So tell them about that, if you don't mind.
Yeah, so when I joined Netflix back in 2014, it's a very different organization today, but this was a little over 10 years ago. The they had this culture called freedom and responsibility, which meant, really, I was on engineering tools, which is a central organization. You've got the app security organization, central organization. We couldn't impose any constraints on what product engineers did. It's kind of an extreme cultural dynamic there. And so think about the perspective of an edge tools person. I'm trying to get folks moving forward on the latest versions of platform libraries. I'm trying to get them to, sometimes company-wide initiatives, Java 6 to 7, 7 to 8, moving from AWS Classic to AWS VPC. So like, there was a lot of like change that we were trying to affect at scale. And one approach to that, and one that's used in many places, is just to set a date, to say that by June 1 we must be on Java 17, and if you don't, and then put a bunch of reports up and meetings and so forth. That was anti-cultural there. We couldn't do that. So if we really needed to get going, we spent a lot of time trying to build reports in ways that were helpful to teams. We would decorate the build log, we'd surface it in their IDE, we'd put up posters, hold in-person meetings, all sorts of things to try to help people move along. And it resulted in approximately zero action. That's what I kept finding over and over again, was that it didn't matter how pretty you made the report. When they were just too busy. And so when you'd ask a developer on a team, and I was asking repeatedly, what could I do, to help you move along? They'd say, well, do it for me, and I'm happy to accept a change. Otherwise, I got something else to do. And I know that was always meant sarcastically, but at some point I heard that enough times that I thought, I think they really mean that. We have to find a way to do work for them if we're going to suggest it as a central organization. And that's really where this mass refactoring technology was born. What's interesting is, I think, as I went on to Pivotal and was working with a lot of more, what I guess you could consider more classic enterprise, is that whether or not they had a freedom and responsibility culture, they had the same dynamic, because you could have thousands of developers spread across multiple time zones. Even if it's a central organization wants to be controlling, they're going to get hard and soft resistance throughout the organization, and effectively that the thing that they're trying to get done won't get done. So I think what kind of was forced upon us as Eng tools at Netflix is actually equally applicable everywhere we go.
Well, that's what we're seeing, which is,
That's what we're seeing.
it's not that developers might not be bothered to do anything about it. They don't have the bandwidth.
They
They
don't
might
have the
not.
bandwidth. Yeah,
They're not compensated on it or evaluated on it, right?
absolutely.
There's other priorities. So organizational structures, I shouldn't say structures, the way organizations are evaluated, if you want, are probably getting in the way of people doing this kind of work. So it's fascinating.
There's a whole
Um,
phrase actually called technical debt, which I think
right.
is a really interesting phrase. We talk about technical debt, and everywhere we go, people say, "Oh, you got a lot of technical debt." Technical debt implies that we've done something wrong as developers, right? I mean, I think in its original meaning, technical debt was like, I took an architectural shortcut in order for an expediency reason to get a product out the door. And now I'm going to have to go back later and I'm going to have to re-architect that at some point. And that's debt that I'm going to have to pay down. But increasingly, what we're calling technical debt isn't a choice that we made. I may have chosen the best pattern, the most current version of something today, and tomorrow that thing evolves at its own pace. That's the nature of using this industrialized life cycle. I'm using components that I don't control the life cycle of. So really, there's kind of two activities. There's technical debt in the classic form, and there's maintenance. And that maintenance burden is taking 30 or 40% of our time.
Is it growing or is it stable?
I'd say it's growing, and I think when we look at there's two organizations I work with at opposite extremes. The smallest one has 70 developers, so reasonably small organization. When I knew them about 10 years ago, they had 40 repositories. That's their whole product suite, 40 repositories. Today they have 1,200, and the same 70 developers they did 10 years ago.
Right. So
that's a small work. I mean,
so they're addressing a smaller and smaller portion of
absolutely. You've
yeah.
got per capita developer, you've got 20 times the amount of repositories you used to have. At a really large bank, I think when we worked with them 3 or 4 years ago, they had about 7,000 applications written on Spring Boot, which seems crazy. What seemed crazy to us at the time. Today they have nearly 25,000. That's the kind of growth in code that we've seen, kind of cross industry, vertical size. Yeah.
For all of you who took the time to join us, I really feel this we are very compelled to promote Moderne because of the wonderful things it does. I think you're going to have some insight into what you can bring to organizations, and you can become local heroes because you're going to be able to do much more than you've ever dreamed of in terms of helping your companies with vulnerabilities, code, application migrations, and so forth. So we have our first question, and I'll give it to you, Neil. Tell me
Great.
when the appropriate time is to address this question, but you're going to
Yeah.
go now into presentation mode. So this is
Yes.
from Lauren Garnick, and I know people are from all over the world that have joined us, so it's kind of cool. Could you please give a high-level overview of the telemetry of Moderne solutions to show how it resolves code vulnerabilities in real-time simulated attack? So I don't know if real-time is the real value here. Maybe it is, but okay, you've got a question. Think about it when you're doing your demos.
Simulated attack. That's something I'd like to get a little more color on there. So, reading the question here, in a real-time simulated attack.
Why don't you do the demo and then
let's ask for more on that one.
Okay, so Lauren, if you can expand on that, and while we let Jonathan begin the presentation of to what does Moderne do, and he'll demo the product. So thank you, everyone. Thank you.
Yeah, absolutely. Yeah, so I want I'll share a screen and we'll kind of orient you to this. We're going to move up the complexity curve. So from a simple thing to a more complex thing over time. And so to start with, what we're looking at is an instance of Moderne. This is a public copy of it that we we put about 300 million lines of open source code in every night. So we're running this as a service for open source contributors in open source projects, but we run a copy of this for each customer that's isolated to just their code. So here we have a marketplace of available recipes, and we have pre-ingested a representation of the source code called the lossless semantic tree. I can show a graphic about that a little bit later. But here, let's dig into something relatively simple to begin with, and I'm going to look at something like common static analysis issues. This is a recipe, and it's a recipe. Recipe is a program, actually, a Java program that does AST manipulation on the source code, and so that's how we kind of affect a particular change. And after the AST has been manipulated, we print it back out, and from that we can generate a diff. So this recipe, common static analysis issues, is actually a composite recipe consisting of a number of just SonarQube style SAST issues, static analysis and security tools. I think SonarQube, checkmarks, Veracode, these sort of legacy tools that report, that show you non-compliant, compliant, but don't help you actually actually fix. We've been rewriting these rules in these rules repositories as recipes that come with auto remediation as well. So if we were to take this composite recipe, I'm going to run this just on 142 repositories initially. And this recipe is going to execute, again, it's a program. So that program is just kind of iterating over all the pieces of a piece of source code. And if we looked into one of the repositories, you would see the specific changes it's made. Note that it's not just reporting this as flagging this as something that's wrong, but rather it's preparing the change for you so that it's ready for you to commit. We can ask on any given file, why did this change? Well, because we're trying to avoid nulls here. And what we want to happen is for a developer to be able to take this change. I've ran this on 142, 65 repositories we've identified changes for so far, 69 now. And what this estimated time savings is just the aggregate of each occurrence of each issue. You see here in SonarQube, it said they estimated it would take 5 minutes to solve per. If you add all those up over a large number of repositories, this is the amount of time it would take to go fix it manually. And what we want developers to be able to do is say commit, and either commit directly, or to create a branch, or create a pull request, or create a draft pull request, create a pull request from forks, the different types of options here. But what would happen is a commit back to the source repository with my name on it. I'm the one that's actually running this. I'm responsible for it. So I should be the author on that. And Moderne is just listed as a co-author. If I cancel this one and run it on the same, I wonder actually if I look at my own code base. So Open Rewrite is the organization where we actually write recipes. If I were to run the same recipe there, maybe we'll find something that we could just go ahead and commit. So I see a number of specific changes here. Look at like this generative AI one, for example. Yeah, that's like a null avoidance sort of problem. I could commit this result directly. And so it's going to take that repository, and if I go and actually look at it on GitHub, notice that commit, this last commit, has me as the author and Moderne as the co-author. And the change that it had teed up inside the platform is now contributed back to the version control system. This should illustrate, I think, where we sit in the software delivery lifecycle, which is to say, we're replacing developer manual work at the front end, making a commit to the version control system, and then the software delivery lifecycle picks up from there. Where, if it's a pull request, you may have reviewers required. It's going to run CI builds, you're going to run tests, so it's going to proceed through the software delivery lifecycle at that point. But we're replacing manual work on the front end of that process, so that you can get things done a little bit faster than you would otherwise do. In the case of let's show one of, before we go into a specific case study, let's show one other kind of change that I think is also relevant here. Share
Jonathan,
screen.
while you do that, so Lauren has a follow-up question.
Oh, great.
When you press commit, is that when you prevent an attack from moving forward? So yes, that is correct. It does that. It would change the code in your repository, but please elaborate on that. Yeah.
Absolutely. But I'll make this note that, like, from the time that the code is committed, is it in production? And not yet, right? There's another piece of the software delivery lifecycle that picks up there. And some projects are going to move faster from commit to production than others, even inside of one organization. I think that's okay. Some require more manual testing, have to be coordinated for whatever reason. But the first step in any remediation is always making the code change, and we're trying to help do that faster.
I've actually thought of an answer that's beyond what you and I are focusing on, and it's my fault for leading. So yes, give me a chance here. I'll add value to the webinar. So it's mean time to resolution, right? So if you think about what Lauren is talking about, You've been attacked, you have an issue, it wasn't identified, now you know what it is, okay? So if you think about where that issue resides, it's probably not a code, unlike some sort of firewall issue. It can be across multiple repositories, often is, tens, hundreds of repositories. So for a company to go out and fix all that will take time. Whereas if you know what the issue is with your solution, you make the change, it'll go across wherever that code is found, and it'll be done rather
Right.
rapidly. So from that perspective, I think that's an advantage. That's a clear advantage. Uh, More than that, though, Lauren, is that with this solution, you're going to cover a lot more vulnerabilities than you would today because you don't have time to cover them. So now with Moderne, you're actually going to get a much bigger coverage and be less vulnerable to future. This is much more of a proactive than reactive offering. This is going to allow you to be much safer than you were before. In fact, Allstate, which is an insurance company that is a client of yours, didn't the chief security officer come to see you saying, "What's
Yeah.
going on? You've solved so
It
many of my
was.
problems."
Yeah, exactly. Yeah, it was the general counsel that came down because which is even more interesting, I think, in many ways. It's that's and that's true in many organizations that you've got executives, whether it be a general counsel, whether it be a CISO, you've got folks that are responsible for risk mitigation inside the organization. And the tools they have right now are really about risk identification, right? Not mitigation. So a scanner that says there's 1,000 vulnerabilities here doesn't actually mitigate anything. It's only when you actually patch the code that it's fully resolved.
Yeah, all that report is telling you is the trouble you're vulnerable to
That's
and
right.
exposing you to the issues, but it hasn't resolved anything. So sorry for interrupting your flow. You were going on to a
Not at
second part.
all. Yeah, not at all. I think so. I told you we'd move up the complexity curve, and so those initial things, we're replacing single statement like avoiding null pointers, these sort of things, like cool, but they're limited in scope. So I think one of the things we wanted to cover here was also migration type activity. And that also can be very, very time consuming and be very, repetitive in nature. So to give an example of this, and I'm going to give an example from Java from JUnit 4 to 5. I find this example to be so interesting because it's unit tests, right? So it's unit tests, so it's not production code. So relatively easy to review, but interestingly, with JUnit 4 to 5, you're not going to be able to go from Spring Boot 2 to Spring Boot 3 without first going from JUnit 4 to 5. And Spring Boot 2 is reaching end of life. And so you wind up getting stuck. And it's not just JUnit, this happens all the time. We wind up getting stuck on old framework versions and old technologies because of some trivial seeming update that we need to do, but that just is very costly in terms of time. So JUnit 4 to 5, here's an example of a PR that we generated for the JUnit 4 to 5 migration. So you get a sense of some of the kinds of changes that are necessary, and it also highlights some capabilities of the core framework I want to point out. The JUnit author changed the word before to before each. They changed the package from org.JUnit to org.JUnit Jupyter API. So I've got to go hunt down every before annotation I ever wrote and make that change, making changes to imports. This run with, Spring JUnit 4 class runner doesn't exist anymore, so you just need to eliminate it. There's much more structural changes as well. Like you used to be able to define an exception on the test annotation, and now you have to use assert throws, put the exception here, and shove the rest of the method body into a lambda. This particular change, I think, illustrates a key point about the underlying refactoring engine in that it crafts changes that look idiomatically consistent in the context of each repository it makes a change on. So here I can detect that this project uses tabs, therefore I will use tabs. When I add this assert throws block, I'm looking at their import formatting. How do they block imports together? Do they use wildcard imports? How many types in a package go into a wildcard import? So the goal is to produce a change that looks like a developer on this project made it, and therefore reduces the barrier for a developer on this project to accept a change and move forward on something. This recipe, we can see this recipe running on that same repository group over here, JUnit Jupyter API or migration from JUnit 4. We can look at one of these changes, and we're dropping just kind of tidying it up, right? Dropping this public modifier. We're even looking at the dependency POM and seeing that test containers for some reason is still dragging in JUnit 4. So we're going to go ahead and exclude that so it doesn't get accidentally included. Just all sorts of different kinds of changes made here. Actually registering extensions. So you see that there's been recipes written to, like, for WireMock rules to actually convert those into WireMock extensions. So pretty elaborate transformations that we're going to make here. And the idea would be that again, you want the developer to just mass commit this across everything. One of the values, and I think this is actually a good illustration of being able to take a recipe and run it across a lot of repositories, is you see where that recipe itself has bugs. Now you see I have an error on this one. If I were to go look at Titus control plane, and I can see the actual exception message here that the recipe threw, looks like we have an assumption about annotation matchers that wasn't correct somehow. So this would be something that, okay, now I have this scenario, I can take this scenario, go write a unit test in the recipe and fix the recipe accordingly. Yeah, that's the framework migration thing. Let's look at this recipe though. I think it's this recipe is also a composite recipe. So it has a lot of different steps to it. To migrate to JUnit 5, you have to, remove dependencies, clean up imports, change these test annotations. And some of these recipes are what we call declarative recipes that are encapsulations of lower level building blocks that we can just supply options to and make change more quickly. And some of them are full on programs. Let's look at one of those just to see what it looks like. This JUnit 4 run with parameterized. If we clicked here to look at the source code itself, note that this is a class that extends recipe, implements the visitor pattern, and we're making some modification here to the actual tree. And so you really have the full expressive power of a programming language to craft change according to what you need at any given moment. There's kind of another example of this, and of how we get change, how we plan for it and get it done. We view search, like code search, as a special case of transformation. In other words, we can hang a little marker on the abstract syntax tree and then render that to show where we found something. Let's look for, this is an actual use case I found somewhere at a customer site that they didn't want to use system.getProperty for some reason. So they wanted to use an internal wrapper instead. So an effort around getting rid of system.getProperty could start with just finding where we're using it, first of all. And I'll match on overrides here. And if I run this, I can look at any given project and see the system.getProperty was used there. When open rewrite recipes look for something like system.getProperty, we don't just have the syntax of the getProperty call. We also have everything the compiler knows about this call at the time the code was compiled. So we know that we can prove that this comes from Java Lang system and not some other system class. In other words, there are no false positives in identifying calls to this particular method here. So I've worked this out. I've ran this over all 142 repositories. This recipe emits what we call a data table. So it emits structured data that we can then aggregate across all 142 repositories. In this case, it emits a data table called method calls. And I'm going to download this as Excel. And the recipe decided to emit basically a columnar format that contains the file that changed and the snippet of code that system.get property call was made with. So you got to wait for this guy to be prepared. We're aggregating these rows across all of the repositories that we ran it on. Let's see if we can run this again here. Maybe if that's not coming up, well, yeah, here it is. So this is I'm going to zoom in here a bit, but this is that data table. And so the recipe has emitted a row with the repository name, the source file name, and specific call to system.get property that it found on every one of those occurrences. So we can use this to study the problem. Now we kind of understand how system.get property is being used across the organization, and we can plan some sort of action on it. If I were to then say change method target to static, for example, this is another recipe that has just inputs. And I could say, let's change that to my internal wrapper, io.moderne.system properties, match on overrides. And now I've actually prepped the code change. System.get property is going to be instead system properties.get property. And I've added the import correctly. I've put it in a place which is idiomatically consistent in the context of this repo. And a developer could go and mass commit this now across the organization.
Which is an incredible value proposition. So we have another question from
Absolutely.
Sharon. Sharon, you can ask a question by typing it in the QA. Do you have it? How does Moderne, how is it able to do what it does? Okay.
Yeah.
How does it differentiate? I guess the question here, I'll rephrase it this way. Why is Moderne so different, right? Because no one else does this at this point. Unfortunately, you kind of wish you had more competitors to give more credence or credibility to the to what you're doing. So how does it do it? Why is it different?
Yeah, we've referred a couple times now to this lossless semantic tree. So you kind of got to reach back to your compilers class from many years ago, and note that when we're looking at code, we're looking at it in textual form. But what a compiler will do is it takes that text and it parses it, it tokenizes and parses, and it produces what's called an abstract syntax tree. And in the first phase of that, you just have the syntax. So this C is greater than 2 would be what's called a binary operation. There would be a little node, a little blue node somewhere in this tree that represents a binary operation. And it has a left and right side. Those are 2 more nodes in the tree. It has the literal 2, which is another node in the tree. And so you build up this tree. What the compiler will do is it proceeds from producing just a syntax tree to then it starts going and traversing it and looking to solve for, well, what is C? Is C an integer? Is it a double? What is it exactly? And it will add what's called type attribution nodes to this tree that fully explain what it's seeing as it goes through. And so you have somewhat of a representation of this on the right, the same tree, but with all the type attribution information, plus all the formatting information, the white space and comments and so forth that originally were in the text form of the code, together produce what we call a lossless semantic tree. So when we're navigating down it, now a recipe is actually navigating down this tree and making changes to it, making edits to it. But we're able to look at all that data. So this whole swarm of yellow nodes here is all the type attribution information that corresponds to some one blue dot here. And it's just an incredibly information dense representation of the code that allows us to make accurate changes, without false positives.
Does it also address scale issues? Because I think you can make changes at massive scale that other technologies would not be able to.
I think what's interesting about this tree being so dense is it forced us down a particular route. Once we realized it was so dense, we actually pulled these repositories into memory it's a distributed system, and we're executing these programs against an in-memory representation of the code. Very difficult system to build. We're deduplicating things and overlaying them. But once we do, the program's performance, the recipe's performance, isn't limited by like database indexes, like lookups and things like that. It's really, really, really fast. And I think you saw that when we were running recipes. It was just running over tens of thousands of lines of code there with it, in a few seconds.
Which is something that you haven't seen other technologies can actually do. We talked about GitHub, right? Why not?
Absolutely.
Let's talk about the elephant in the room, GitHub, because you're
Yeah.
thinking, why can't they do this? And I think you actually met with GitHub and you spoke to them, and their
Yeah.
searching capabilities cannot go as fast as you guys can.
And ultimately, their searching capability is built on the text portion of this. When you think about it, that's what GitHub actually has as its permanent storage. They have the text of the code. To our company, the former CTO of GitHub is an angel investor in our company, the former head of sales at GitHub. And what Paul saw, or Jason saw, the former CTO, was that really long term, this LST representation is really how code probably should be stored, because the textual form is very lossy. I can't resolve just by looking at the text what C is. And therefore, the kinds of programs and decisions and analyses I'm going to be able to do on the text are limited. And so that, I think, is going to always be true. We're producing these LSTs as a side effect of your normal CI process. So we always have an up-to-date copy, but we know everything the compiler knows about it. So it's a much, much denser representation than the text itself.
So when you say that, I hear we're just at the beginning of Moderne's journey in terms of its
Absolutely.
capabilities, right?
Absolutely.
But we only have 1 hour webinar, so we're not going to
I
talk about the
know.
future right now.
Right.
But what it does today is fascinating. So everybody, I'm a clear proponent of Moderne. I love what it does. I love what Jonathan and Olga have put together. Olga is the co-founder with Jonathan
Absolutely.
who built Moderne. So for the rest, my mantra here at Optica is we want to create more people who believe in this and who push this internally. Now, some of the challenges of this is, again, it's not a mature market. Everybody has scanning tools, but who the hell
Yeah.
has automatic code remediation?
Right.
Not many. So one of the things that I learned in talking to you is your case studies. They're quite compelling. So let's go there for the last few minutes of our demo.
Absolutely.
Take us through some of the case studies so that the people who are participating can see what kind of business case that we can help build for them. We're not going to let the people that are on the call build it on their own, but if they want to get an order of magnitude, they can say, "Oh, we can prove this relatively easily and
Yeah.
fast." And the
Yeah.
scale of the business case is quite compelling. So if you don't mind, take us through a few case studies.
Yeah, I'd start with this one, I think, and this is I won't name them specifically publicly here, but this is one of the top 5 Canadian banks. So it's massive organization, um, highly regulated, I'll point out, and so they're very sensitive about the intellectual property of their source code. I think that's a testament. The fact that we're working with them is a testament to the security of the solution and how well that's been vetted inside their organization. But at any rate, there's been kind of multiple things they've been doing. And this first one, actually, if we kind of read right to left, this SAST related remediation, that's the one I demoed first. They gave a really conservative estimate here that it took them, on one business unit down 74% of the time it would have done to do it by hand. The Spring Boot 1.1 to 2 migration, very manual lift. On a set of repositories took them from 70 hours to 17, which was 17 was really the review time and pushing it out to production. And so most of the manual work of making a code change, that's the difference between 70 and 17, was handled by the platform. And then, you just saw for yourself the JUnit 4 to 5. That just think about this: 3 projects, right? Those projects had thousands and thousands of unit tests. So that those same changes you just have to make over and over and over again. This is really tedious stuff. Those are the things that are perfect here. We took from 900 hours down to 127. And that's just really the beginning. These kinds of changes are not one-off, right? As developers, we've experienced that. The ecosystem of libraries we depend on continues to evolve out from under us, and always will. That's the state of the world now. It's a one of constant change.
Can you put that slide back up? I want to
Yeah,
explain something to
absolutely.
everyone. So for everyone, please pay attention to the bottom left, which is just one use case, the JUnit 4, the JUnit 5.
Right.
They had estimated 900 hours, and it only took 127 hours. From a dollar perspective, that's in excess of $95,000 of savings on this
Yeah.
one particular use case. I don't know how many days that this all took, Jonathan, but I believe it was less than 3 months that they did all this stuff. I could be wrong
Yeah,
about
and
that.
yeah, and they were very early customers. So
Very early
now
customers.
this
But sorry,
process of getting, say, 200 or 300 repositories into the platform and doing this one on the right, the SAST one, this is about a 2 to 4 hour effort on behalf of new customers. It doesn't
okay,
take very long.
doesn't take very long. So they just these 4 use cases alone, I believe the bank reported internally, they saved in excess of $115,000 on this small evaluation. So for all of you that are watching this webinar, this is just initial phase, initial trial value proposition. So it's quite
Yeah,
compelling. It's easy to prove. If you have concerns about, I'd love to bring this in, but I'm not sure. Let us have a discussion with you about it. We can help you build business cases with actual benefits within your organization. And that's kind of where I wanted to end this, Jonathan, unless you had something else to add. But I wanted to say, look, you took him through 2 important use cases: code vulnerabilities, application framework upgrades. Uh,
absolutely.
and now we showed him all uh, the value, actual, real, tangible, quantifiable value on top of 2 other beautiful ones, which is greater coverage of code vulnerability
Yep.
remediation and de-risking, which executives care deeply about. De-risking. I want to go to bed at night. I don't want to be worried. With Moderne, I know I'm going to have a much greater coverage than I can have today.
Yeah.
So if I want to, we're okay. So Lauren, question number 2. Where are we with our GTM strategies? Or would that be more a question for John and Mike? GTM,
Go to market.
go to market.
Sure. I mean, so that's a deep topic. We could probably talk all day, but I'd say in general, the way we think about this as a product and like kind of how it's priced, we want it to be fixed cost, predictable for end users. So we charge by line of code under management and per user cost. Those are both predictable measures, and then do as much transformation as possible. So inside of our organization, we evaluate our teams on the basis of how many commits developers are doing at customer sites. We want to see them just get a lot of work done very quickly. But we're honestly kind of against usage-based pricing models. We feel like you should be able to, we just need a proxy of complexity. We're capacity planning our service on the basis of how much code and how many users are using it. And then we want to see you win, right? And do as much work as possible on the back end of that.
Yeah, so right now we're working jointly with Jonathan and John and Mike on an evaluation process that is constrained in terms of not number of lines of code, but in terms of timeline that allows you to gain value, but roll right into an enterprise agreement once you've proven that value and you can move forward. You'll hear more about that, Lauren, from us. If you want to learn more, you can respond to one of our emails, but we're putting together a program to allow you to be much more successful in proving this internally. Uh, we're very incented. We're very incented to help you out. So, Jonathan, I thank you very much for
Thank
doing
you,
this.
Ron.
You know how much we think you guys are. We think you guys are awesome, and we're proud to be partners. I'd like to thank
Absolutely.
everyone who joined us. Everyone who joined us, you're going to get some follow-up emails from Alyssa, who's probably the ones that you've heard the most from. Um, we're going to take this recording. We're going to publish it on, well, I'm going to get Jonathan's permission, but we're going to publish it somewhere where everybody can get access to it and see it, and allow you to share with others who are maybe concerned about talking to sales reps and other people who want to be left alone but want to learn more. So we're going to give you a less intrusive way to promote this to your peers, friends, whatever, who you think this might be valid for. So thank you to everyone for joining us. Jonathan, thank you very much.
Thank you.
Always a pleasure talking to you. Everyone have a very good day, and hopefully we'll see you on our next round of webinars. Thank you, everyone. Bye-bye.
Very good. Bye now.